going to say something else because that's what it is. Spring One Tour. And we have with us the Josh Long, as I like to call it, the Josh Long Experience. Josh, where are you, my friend? I can't see you. I'm searching for you. Where are you? Come on up. There he is. Good morning to you. We are on the West Coast. You're down in Los Angeles, City of Angels. You're where you were born and raised for a while, correct? Is that your roots, your origin? Yeah, and but now you're a Bay Area boy. BAB is I just made up. And we're excited to have you on the show today. Good morning. I can't wait to hear all of your great Reactive Spring stuff. That's what today is happening, right? Reactive Spring?
Yeah, we're going to be reacting to Spring. It's going to be, isn't that what that means? Something like that. We're going to be doing Reactive Spring today. It's going to be awesome.
Spring's going to be coming at people and they're going to be going, whoa, whoa, and you're going to show them how to react to it, right?
One hopes.
Where's my laugh track on that one? No, they didn't deserve it. You're right, Paul. You're right. It didn't. We have so many people working behind the scenes that we might be referring to them by name, but yeah, Paul Zarkowski. Thank you. There it is. It's definitely going to be helping us with our laugh track and applause-o-meter today. So, Josh, how you feeling this morning?
Faboo. Excited.
Nice.
Yeah. How about yourself?
I'm doing fine. I've got my coworkers playing the Casio keyboard on high in the other room. So if you hear that, they're just having a little dance party to the pre-tuned music on the keyboard. So,
well, right on.
Yeah, when you have 5-year-old and 3-year-old coworkers, they focus for a little bit on the job at task, and then they're easily distracted. It just
they could be the house band.
That's right. That's right. Play me off, kids. And that's a scream. So that's my call. Anyway, but I'm excited. Today we have 2 hours of Reactive Spring content from you. And then tomorrow, everyone at 9 a.m. Pacific time, we'll be doing some quick tips with the Spring. So when you're listening today, you have the Q&A button down there. You can start asking some questions. And if we have any time at the end, which I'm pretty sure we won't, just because Josh has got so much knowledge in there that he's going to be dropping it all for the next 2 hours. But anyway, if you have questions, add those to that, and we'll make sure that we try and address them tomorrow during our.
Can we do them after? Tips. I have no upper bound at exactly 2.
Oh. Yeah, I mean we kind of have a 2 hour time limit here.
Okay, I'll try and get it all in.
We've got some friends like Sweet Killer 9. They're in like Romania, and so it's I don't know what time it is over there.
Right. Plus late. 9 or 10 or 11 going to Europe. 8 o'clock and plus 8 in UK, and then hours more afterwards.
It's probably at least plus 10. But anyway, so we want to thank all of you for joining in, and hopefully you get so much information that you can use this towards all of your future projects. And so that's what's happening today. 2 hours of Spring tips, Reactive Spring. Tomorrow, an hour of Spring tips, and all with Josh. It's great, and me.
It's gonna be fine. Yeah, and Bob. That's why I'm here. I'm here for Bob. I'm Team Bob.
And we've got Paul and Newt and Jamie and Tasha, and Yvonne's going to be on the questions and answers, answering and taking in those. So just let's have a great time, everybody. Let's go team. Spring team. Let me just make sure I have everything checked off before we move on. Yeah, I think that's it. I think I just want you to get going here, buddy.
Should I go? Is it time? Did we ring the bell?
I think I can ring it for you if you'd like.
.spring.io. Yeah.
There it is. Your second favorite place to be on the internet.
All right. Thank you, everybody. Good morning. And just echoing what Bob just said, there are so many people involved in making this thing awesome. And then they went and chose me, which is, they got that close to making it perfect. And then they added me to the roster, and that's not great. It's not no good results are guaranteed from that. But everybody else involved thus far, and all the production management, scheduling, everything else, just legendary. So I'm really grateful for the opportunity. I'm so glad to be before you this morning, my friends. I'm acutely aware of the fact that there's places you could be. Well, in a pandemic, maybe not places you could be, but there's things you could be doing, right? There's other things you could be doing. We have your attention for a few hours. I appreciate that. I know that there's other things you could be doing. Like I said, it's not like we just run out of things to do when we go to these conferences. We choose to deprioritize them so that we can participate in these conferences. So in that vein, I really want this to be a fun experience for everybody, and I want your questions to be answered. And I'm hoping that I'll get, just in the natural sort of sweep of my talk, I'm hoping that I'll get to your questions. But should I not, what I'll think I'll try and do is maybe I'll take questions midway, at the hour mark, and then I know that it might be late. I'm happy to stick around, and hopefully I'll have a few minutes before, but I'm happy to stick around a few minutes after, and so on. But obviously, that's just the time that we've got today. That's not the only time that we've got together, though, my friends. My goodness, we on the Spring team and here at Tenzu are forever at your service. And so as a result, I've always liked starting my presentations with this slide or something like it. And this slide is arguably the most important slide you're going to see this afternoon, or this morning, or this evening. It contains my coordinates. It's going to contain all the things you need to find me should you have questions. So there you'll find my Twitter coordinates at StarbucksMan. You'll find my email, josh@joshwrong.com. And of course, you'll find the code that you're going to need to be able to follow along at your own leisure later on. Not now. Definitely not now. Don't. Yeah, what I would do is I'd just take a screenshot. Just take a screenshot of that slide, and then, hang out with me for the next couple hours. And then you can go clone that repo and dive in. So, a little bit about myself. My name is Josh Long. I'm a Spring developer advocate. I have been. This is 10 years now. I've been a Spring developer advocate. Actually, no, I'm not. You know what? I got ahead of myself. 3 August of 2010 was day 0, and 3 August 2020 will be 10 years, that's fun. That's a lot. That's more than 0, and it's less than 1,000, but it's not nothing. I'm excited about that. So 10 years in my official capacity as the first Spring developer advocate, and then I am a Kotlin GD, so Google developer expert or whatever, and a Java champion. Those things are sort of titles, they're honorary titles as opposed to a job description. But hey, I'm proud of all of them. I'm on Twitter, like I said. I'm on email. So again, just please, if you have questions, comments, feedback, whatever, don't hesitate to reach out to me. A little bit about myself. I work on the Spring team. I have some training videos that are out there on different topics, some of which you may find interesting. These are on Safari mostly. These are on all sorts of different topics. Continuous delivery, Kotlin, Cloud Foundry, Spring security, building hypermedia, RESTful APIs, microservices, all that stuff, right? If you see before you a number of videos that look interesting, as a rule, I find that the best ones are always the ones where somebody else is with me. So I've, for whatever reason, been lucky enough to be able to trick amazing co-presenters like Spring security lead Rob Winch, like Spring Boot lead Phil Webb, like Spring Cloud Contract lead Marcin Grzesiak, and like Cloud Native and Cloud Luminary Josh McKenty to co-present with me over the years. And these videos are infinitely better than the ones where it's just me. This is why I feel like it's worth mentioning right now up front that there's no refund for the next 2 hours. You don't get anything back. So, there's that. I have a book I wrote called Cloud Native Java back in 2017. It's all about how to build applications that survive and thrive in the cloud in terms of Spring Boot and Spring Cloud and Cloud Foundry. It's out there in a number of different languages. I hope you'll find one that's palatable or appealing. I have a podcast that I put out every Friday. So this is just, this was originally the idea was, hey, I bounce around from city to city. I go to different places on this particular globe of ours, and I talk to people. And I'm lucky because I'm forever meeting interesting people, be it my colleagues on the Spring team or just people in the Spring and Java communities. And I just figure, gosh, wouldn't it be nice to turn on the microphone and make everyone else privy to this amazing conversation that I feel so very lucky to be able to have with these amazing people. Because I'm learning things. I love learning things, and I'm not very smart, so it's very easy to teach me something. So I feel like it's just really nice to be able to have that opportunity. And that was before the plague. Well, now here we are. in the thick of the plague, and I don't get to bounce around from city to city anymore, as you can imagine. So now it's actually kind of cathartic. I just enjoy having a reason to instigate a conversation with people. Either way, a lot of stuff, a lot of good stuff to learn there. Really interesting people, myself excluded, of course. I have a blog thing I do called This Week in Spring. That goes out every Tuesday. So yesterday there was another installment. I also do a thing on the Tanzu website. It's a blog. It's called This Month in Spring, but it also gets wrapped up into a newsletter. So that Get the Spring newsletter, if you were to put in your email there, you would have been subscribed to our newsletter, and you would have gotten the latest and greatest content. You would have gotten this as an aggregate, as a digest for a month. So there's that. And I have a screencast series called Spring Tips, where it's just me looking at some corner of the ecosystem, some bit of Spring arcana. And these are deep dives usually. So lots of different topics. There's a lot more videos now. I do 11 episodes per season, and I just take a few months off between seasons, and so there's good many number of episodes now. And of course, I've got a book called Reactive Spring, and that's really what we're going to talk about today is Reactive Spring. By the by, friends, I'm here, and my Wi-Fi is when it's working, it's great, but it sometimes tends to flake. So what I'm going to do is I'm going to just not overwhelm it. I'm going to stop the video, and I'm going to make sure that if it flakes, don't worry. I'll be back in a few minutes. Just keep that in mind. Okay, so we're going to talk about Reactive Spring, and really, in order to do that, in order to have that discussion, in order to appreciate why we're here, we need to contextualize reactive programming in general, just the idea, right? Why do we care? And it's not hard to point to the things that sort of motivate it, right? Things like the convergence of microservices with cloud computing, the return to the client service era, etc. All these things have driven more network requests, and they have resulted in more traffic to our services, and that in turn has resulted in a situation where our services are no longer nearly so scalable as they need to be able to withstand the demand that we're placing on them. And so the question has become, well, what do we do? What can we do to better scale, to better meet these demands? And of course, for the last 10 plus odd years, we've had a sort of pragmatic half step, and that is namely microservices, right? Microservices give you an architecture where you excise any state from the web service and you push it back up, or rather to a different tier, namely the hopefully horizontally scalable cloud native database, something like Cassandra in the classic Netflixian sort of sense of the term cloud native. And there, if you have any state, you can scale out there, right? You can scale out at the database tier. So your web service itself shouldn't have any state, right? And the benefit of that is now I can throw different instances of my web server behind a load balancer and then just scale out horizontally. I can just use a round robin load balancer to divide traffic across the number of instances that I've got. And should I need more instances, I just spin another one up, and the load balancer will take care of it, incorporating or involving that node. This is a great result. Okay, this is a very convenient result, because what we get is the ability to handle more demand without having to figure out why we can't handle more demand with our existing nodes, with our existing infrastructure. And that is the question that we want to address today, my friends. You see, while microservices and while that architecture and while scale out in that fashion has served us well, it's still rather inefficient, right? Because a lot of it should be possible to handle more traffic with the same JVM. And I think it's worth answering the question, why can't we? And then once we've done that, once we've actually built services that are out in the network that need that kind of scale out, we are now then faced with another problem. We are now building a distributed system, and we've risked running afoul of the fallacies of distributed computing. And there, my friends, is a lot of peril, right? A lot of things we want to avoid. And so the question then is, how do we write software that is aware inherently of the potential peril of building distributed systems, the fact that things could fail, the fact that services may flame out, that topologies may change, etc. For that, we need a different programming model as well. So we have two different problems. One, we want to scale, and two, we want to be able to better write software to respond to the inherent volatility of the cloud and to that scale. So that's what reactive programming gives us. It's a solution for both of those problems. And obviously, the technical nature of it, the technical reason that we care about reactive programming is because when people are building software, when they're building software in the JVM, traditionally that software was hard to scale. It takes a lot to be able to add threads to the JVM, right? The JVM does not like threads. It doesn't do a very good job of creating threads cheaply. That will change, hopefully, in the near term with Project Loom. But historically, it's not been great, right? So what we want is some way to make it easy to take better advantage of the threads that we've got, rather than having to create new threads, because it's not easy to do that, right? And so this implies a change in the programming model. This implies a change in the way that we write software, and that's where reactive programming comes in. It's a mechanism, a protocol, an API that allows us to write code that does asynchronous things, right? Things where the flow of execution may happen asynchronously, it may happen latently, it may happen, in the future. And when it does, we want to be involved, but no sooner, right? We don't want to be involved in that asynchronous code if we don't have to. So that's where reactive programming really comes in, is it gives us a way to describe essentially latent, potentially volatile, potentially asynchronous, potentially unbounded data flow, okay? So we need to actually take that abstract idea and make it real. And this is where Spring helps us, right? This is where Spring can offer us an opportunity. In 2017, the Spring Framework team released Spring Framework 5, which is the first version of Spring to incorporate native support for the reactive programming model, on top of which we have since released Spring Boot, Spring Data, Spring Security, Spring Cloud releases, all of which incorporate wherever possible.
We're gonna.
What just happened? Wow, that was bizarre. Okay, my speakers just changed. I hope you can all hear me. Okay, so what we're going to do is we're going to take a look at all that stuff. We're going to see how these things fit together. We're going to do that, of course, by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is start.spring.io. It's my favorite place on the internet.
.spring.io.
Exactly. Yeah, what he said. But if you can't get to, if you're not already in production, you can begin your journey here at start.spring.io. So what we're going to do is we're going to build some new software, taking advantage of all these bits. We're going to use Java. We're going to use Maven. I'm going to use the latest and greatest version of Java that I can, Java 14. But you could use Java 11. That's a current long-term supported version of Java. That's fine as well. I'm also going to use the latest and greatest version of Spring Boot. And there's a number of reasons for this, friends. A number of reasons for the latest and greatest version of Spring Boot. Spring Boot 2.3x is packed with tons of really, really powerful features that make building cloud native applications even easier. And so what I mean by that is, first of all, there's a common theme in Spring Boot 2.3 that's designed to support Kubernetes, among other things. So things like graceful shutdown. So you can actually, if the platform comes along and kills the container in which your application is running, the application can stall for a minute, or a configurable grace period, and it can stop accepting incoming requests, and then it can allow the existing work in the pool to be drained off, and then it can shut down gracefully. So you don't end up terminating in-flight transactions. There's also availability probes. There's also support for building Docker images out of your application. So you can say spring-boot build-image, and it'll use the Cloud Native Computing Foundation build packs to then generate a consistent, sensible Docker image or container out of your application. It'll take your Spring Boot jar and turn it into a file system that has everything that's required to run that jar, including a JDK, including all the latest, including the latest JVM and so on. And obviously that's configurable. You can even go so far as to actually prescribing how Spring Boot should layer its so-called fat jar so that it participates nicely in a container environment, wherein, for example, you can have application code on one Docker layer and then libraries or dependencies that are fairly fixed and static on yet another layer, and application resources on another, etc. Things like that. So now the delta between one Docker registry push to another can just be bytes instead of 30, 40 megabytes. So really, really compelling. One of my favorite features, however, is the support for native images with a Growl VM. Okay, so Spring and Growl, there we go. So Growl VM is a C1 just-in-time compiler replacement for OpenJDK or for JDKs in general. And you may know about Hotspot. Hotspot is a well, first of all, it's famous. It's got a patent and so on. It's actually a very interesting piece of technology. It is a piece of code that analyzes the runtime behavior of your interpreted Java code and says, hey, that particular segment of code would be much faster were we to compile it to native code. And there's no reason why we couldn't. So let's go ahead and dynamically compile that in flight, and then replace the code segment that was otherwise interpreted with that native code. So the rest of your application is still interpreted, it's still just loading class files and interpreting them. But when it gets to that one particular segment, it's going to load the native code from the disk and then execute that, and that's much faster. So this can be very nice, but the problem is to enjoy that, you have to warm your application up, right? So Google and all the large websites do this thing all the time. They'll start an application and then they'll invoke it, they'll run it, they'll actually exercise the application 10,000 times or whatever, just to make sure that the Hotspot compiler has already been aggressively applied wherever it would be useful, so that by the time it gets put into a load balancer for actual production traffic, it's already as fast as it's going to get, right? So the question is, if it's so fast and it's so nice, why couldn't we just compile the whole thing into native code? And that's a great idea, actually. That's called ahead of time compilation. So you can actually use a feature in Growl VM, which is not a standard part of the OpenJDK sort of arrangement yet. You can actually use a feature in OpenJDK, in Growl VM, to build a native image. Now, this is a very useful feature, and it's such a useful feature that it's now been targeted for inclusion in the OpenJDK. It's called as part of something called Project Ledin, Ledden or On, and that's going to be fun. But for the moment, I would encourage you to check out Growl. And in order to use these native images, you need to run your code through one more compilation step. I wish it was just as easy as that. The problem is that when you do this, when you turn your code into native images, the Growl native image compiler has a few things that you need to change in your code. It hates a lot of things that I think we would all agree are part and parcel of Java, right? So think about all the things that you'd be hard pressed to do in C++, and then those things apply here, right? So things like dynamic without a priori knowledge reflection, not great. You need to tell Growl about what you're going to reflect upon. You can't just like traverse every single unknown class and hope that works. The use of you can't dynamically create classes, or you can't dynamically register classes with the class loader. If you're going to do proxies at all, they need to be JDK interface proxies, right? You can't use any other kind of proxying technology. So these kinds of limitations, not great. They do tend to thwart a lot of the useful functionality in the JVM ecosystem. That said, we're working steadily to make it so that Spring can do a 99% of the work for you without those technologies, without those particular things happening. And we're already a good way there. So we've got a project called Spring Growl, Spring Growl, I think it's called Spring Growl or Spring Native Image or something like that. It's a project, it's open source. It depends on Spring Boot 2.3, and you can take your applications and compile them. I did a Spring Tips video on this very topic just a little while ago. So let's start with the slowest. I'm going to go to my Apache Tomcat and my Spring Data JPA plus Hibernate example. Now these are, you've used Hibernate before. You know that there's going to be a number of moving parts there. I've compiled it into a native image here, and I get this thing here, right? So if I look at this, I look at the size, it's 169 megs. So, markedly bigger than a so-called fat jar, because this includes their virtual machine. There is no JVM anymore. This is not, technically speaking, Java anymore, right? This is actually a very incompatible architecture-specific format. You can't take this you can't take this binary and then run it on Linux or on Windows. You need to compile it or cross-compile it for those platforms. But for the platform it's targeted to, it can be very impressive. So here we go. Let me run it. There you go. So I just ran the application, to finish in 0.26 seconds. So less than 0.3 of a second to get that working. And it's talking to JPA, talking to Tomcat, doing all the things that, applications do. And if I go here, Control C, refresh, there we go. It doesn't work anymore. Okay. So I can now go to the MongoDB application. This one's a bit faster because it's using Spring Data MongoDB instead of a Hibernate, but it's still using a servlet container, right? It's still using Apache Tomcat and so on. So target and then native image. And then we're going to run MongoDB. We're going to run the Spring Data and Apache Tomcat web application. Okay, there you go, 0.17 seconds. So just a little bit more than half as slow. Like it's the last one was almost 3 seconds. This is almost 1.5 seconds, right? This is a little bit more than 1.5 seconds. So, there's the application now. Very, very fast, right? Very, very, very fast. So there you go, 0.15, etc. And now we go back to our reactive application. As you can see today, reactive applications are just really fast off the line anyway, regardless of whether you're using Growl. They're not as fast. They're not so fast as if you are using Growl, but they're fast, right? They're fast enough that you don't really notice them starting up anymore. So native image, reactive. The first run, for some reason, on a computer that hasn't run these before, I think the operating system doesn't like me running native code without it knowing about it. So it does a check. So 0.116 seconds. So effectively 1/10 of a second. And, it can be, I've seen it go below 0.1 seconds, obviously. So really, really fast as well. And there's that, right? There's the reactive application that's talking to a SQL database, in this case, H2. And it's using R2DBC and the reactive web stack and so on. And we're gonna look at all that stuff today. But either way, very compelling features, all part and parcel of Spring Boot 2.3, and I encourage you to use it for any of those reasons and more. Okay, so we're gonna build an application here called a service. We're gonna use a number of different dependencies to make our life a little easier. We're gonna use Lumbuck. We're gonna use the reactive web support. We're gonna use R2DBC. We're going to use PostgreSQL, which is a SQL database that I've got running on my local machine here. We're going to use security. We're going to use RSocket. And what else are we going to use? What else do we need to use? I think that's it. I think that's, oh, we want to use MongoDB. Do I have MongoDB? I don't think I do. So bring in MongoDB. And with that done, I have everything I need to be productive. So I'm going to generate a new application. I'm going to use Java 14. Everything I'm going to show you here, save for perhaps a little bit of the Java syntax, could be just as easily done in Java 8, right? There's nothing in what I'm doing here that requires the latest and greatest version of Java. It's just the right thing to do. It's technically the right thing to do, to use the latest and greatest version of Java. Obviously, the new versions of Java are faster. They have more syntax, more features, more runtime benefits, and more secure. They're just better all around. They're also morally superior, right? Because again, you're not going to enjoy the look of revulsion and disappointment in your children's eyes when they find out that you're still using Java 8 in production. That's not a conversation you want to have. Trust me, use Java 14. Okay, so we're going to hit generate, and that'll give us a zip. That was okay. So we're going to build a new application, a service. We're going to open this up in our IDE, and again, any IDE will work just fine. I'm going to use IntelliJ, but again, to each their own. Okay, so the first things first, we're going to comment out some of the dependencies that we don't need just yet. So for example, I added security, and for the moment, just for the moment, and don't tell Rob which I said this, but for the moment, that's going to get in our way, right? Just for the moment, we don't plan on leaving it that way, but we're going to comment it out for now. We're going to comment out Spring security itself. We're going to comment out R2DBC, okay, because we don't need the R2DBC support just yet. going to comment out the JDBC dependency because we have absolutely no need for that at all. And what we're left with, at least at the get-go, is a reactive MongoDB application, a reactive web application, an RSecond application, and Lumbux. I'll bring in those dependencies, those changes there, and we'll go ahead and start. So what we're going to do is we're going to write an application that talks to a database. Obviously, this is a Spring Boot application, so I'm just going to go ahead and create an entity that we can map to a document in my MongoDB instance. I've got MongoDB running in the local node on the background here. And that actual app, that database has a slightly different domain model, slightly different approach to modeling your data than a typical SQL data store. In MongoDB, you have a collection. Collections are kind of like a table, and then each row is called a document. So I'm going to map this Java object to a document. Obviously, this is Java, so I want getters and setters and toString and all that other stuff. So I'm going to use Lumbux. Lumbux is a compile time code generation mechanism. It'll synthesize those getters, the setters, the toString, the equals, the hash code, etc. And I want to then write that data to the database. So I'm going to create a repository. Now, this repository is just, typical Spring data. I'm sure you've seen these repositories. I'm sure you've seen these types. This repository has several methods here that support saving, finding, deleting, counting, etc. Records in your data store. The name should be altogether fairly familiar if you've ever used Spring Data. What may not be so familiar are the types that are being accepted as parameters and then those that are being returned, namely the publisher. Now, the publisher is part of the Reactive Streams specification. So earlier I spoke about the need for an abstract, sort of ubiquitous component model that allowed us to describe latent, potentially asynchronous, potentially unbounded streams of data. This is served by the Reactive Streams specification. It's a set of interfaces that were extracted out by the Spring team, along with Netflix, along with Lightbend, along with the Eclipse Foundation about 5 years ago in 2015. And these types are just a set of common ground interfaces that are the absolute basics, the absolute minimum that's required to be able to say, this is a reactive stream. And they're foundational, and they're so foundational that they've since been incorporated almost identically, save for the package, into the JDK themselves. So here's publisher or Reactive Streams publisher. There's also Java util flow, and then inside that you can see Java util flow publisher, subscribe, subscriber, and so on. So we're gonna see that these things. You should see that these things are interchangeable, and if you're using Java 9 or later, which you should, then you can use either one. If you're using Java 8, then really this is the only option you have. But either way, these types are worth understanding because they're going to be used a lot across the ecosystem. So we have a thing that produces data, and it's going to produce data destined for a subscriber. The subscriber will subscribe to the publisher, and it'll consume that data asynchronously out of band. When it first connects to the publisher, it is given a subscription. That subscription is arguably the most important part. We're going to come back to that in just a second. Let's put a pin in that ever so briefly. But when records are published to the subscriber, they are conveyed here in the onNext method. When there are errors, when ineluctably there are errors, that's communicated here through the onError callback. And then finally, when the publisher has nothing more for us to process, it's communicated through the onComplete callback. Now, let's talk about that subscription, right? We've got publisher, subscriber, and now a subscription. The subscriber keeps a reference to this subscription. The subscription represents the connection for the subscriber to the publisher. And it is with this that the subscriber can ask for more data, or it can stop the production of the data, right? So here it can say, I want 10 more records phase, or 1,000 more records, or however much it feels it can handle without overwhelming itself, basically, without having exceeded its capacity, right? And this is very important, right? We as a consumer don't want to consume more than we can handle. And so this API gives us the ability to push back to say, hey, I don't want any more data, thank you. I'm happy, I'll be able to process this. And when I want more, I'll just request more. So the publisher will never give the subscriber more than it's asked for. It may ask for 1,000 records, and you might get 1,000 records, but who's to say when? You might get 1,000 records all at the same time, basically, all in the same few nanoseconds, or you might get 1,000 records over 1,000 years. There's really nothing prescribed there at all. So what you have to understand is it's really about what you feel like you can handle safely in one fell swoop, right? What can you do in one go? The effect is that we have the ability as a consumer to control the rate at which we consume data. We have the ability to push back on excess data. This is flow control, right? This is what happens when you have one thing on the computer that talks faster or slower than the other. We need some way for these things to regulate their speeds. And this is not a new idea. It's not controversial in the slightest. It's one of those things that ever since we had one computer on the same network as another, we had to care about flow control. Okay, so we've had flow control for forever, right? This is just a thing that we've now surfaced as part of the API. That's the novelty here. That's what's so impressive. In the world of reactive programming, sometimes flow control is alternatively called back pressure. Okay, so back pressure is a way of saying I don't want any more data. So now we've got those three types. The fourth type, we don't even see it here, is called a processor. And you won't run into this too often, but it's worth knowing about. It's a bridge. It's a source and a sink. And there you go. Congratulations. If you understood those four types, publisher, subscriber, subscription, and processor, you understand the Reactive Stream specification. You're already light years ahead of most people in Silicon Valley. So I invite you, come to Silicon Valley, start a new company, raise millions in venture capital funding, and blow it all in lavish parties and exit a failure like the rest of us. You're fine. You're ready to go. These APIs put you light years ahead of most of the people in the Valley. So good stuff, right? Very, very simple APIs. Like I said, they're foundational. They're in the JDK, but they are kind of Spartan. They don't have a lot of support for operations on those streams of data, things that we would use to process, to composite, to interact with those streams of data. For that, we have two specializations from Project Reactor. So remember, I've just introduced the Reactive Stream specification. Project Reactor is a separate project that builds upon the Reactive Stream specification, that integrates those APIs. It builds upon those APIs. It specializes those APIs into two distinct types. One is a mono. A mono is a publisher that produces 0 or 1 record. It's a thing that produces 0 or 1 record, and it has a number of different operators that allow you to work with that data. So things like defer, handling errors, doing composition, filtering, mapping, flat mapping, etc. All that is here for you. And mono is a publisher, but it produces at most 1 value, as compared to a flux. A flux is also a publisher. It's also a type from Project Reactor, but it produces 0 to n values, where n is potentially unbounded. Okay, and again, very, very convenient, very nice types. The semantics are different, right? If you want something like a reactive back pressure aware Java 8 stream, use a flux. If you want something like a reactive back pressure aware completable future, use a mono. Okay, the semantics are useful there. One is a great way to communicate, 1 or null, and the other one is a great way to communicate 0 to n, where it could be potentially unbounded in this case. All right, so we've got our repository. Now let's write some data to the database. We're going to go ahead and create an initializer like so, and an event listener, application ready event, class, public void begin, add component. Alrighty, private final. And what we're going to do is we're going to inject a reservation repository here into the constructor. I want that to be made available. So I'm going to use Lombok. Lombok's a compile time annotation processor. As I said, I'm going to use that to synthesize that constructor. And here, I'm going to just create some names. I'm going to list some names of people who are on the Spring team. Myself, I'm Josh. Nice to meet you. I'm on the Spring team. Who else is on the Spring team? Yushin, she's on the Spring team. There we go. We've got, who else is on the Spring team? Dr. Sire, of course. He's on the Spring team. We've got Olga. She's on the Spring team. We've got Madura on the Spring team. We've got Violetta. We've got, who else is on the Spring team? 1, 2, 3, 4, 5, 6. We need 8 names to have a nice round number. It'll be divisible by 2 and then 2 again. Makes it easier for us to sleep at night. So who else can I mention? Oh, Stefan, right? Stefan, he's on the Spring team. And of course, Ilya, he's on the Spring team. There we go. So there's 8 names of people on the Spring team. And for each name, I'm going to visit the record. I'm going to turn it into a new reservation, passing in null. and I'll create a new stream of reservations. And what I want to do is I want to save this stream of reservations to the database. Now, I haven't saved it to the database. I've just created out of these names reservations. It's a stream of reservations that I created from a stream of names. And then from each reservation, I'm going to call map there reservation. And I'm going to say this.reservation repository at save passing in reservation. Now, the problem here is that save in turn returns a mono. It returns a type of publisher, a mono of T. And map accumulates the results of the Lambda into a container type. So I have a container type, in this case, a flux of instances of the thing that gets returned from save, which is in turn a mono of reservation. So it's a publisher of reservation, right? That's what I get if I run this code as is, like that. It's a publisher of reservation. Obviously, that's the specializations, but I can use that, right? Whoops. There we go. Come on. Publisher of publisher. So I don't want two reactive streams. I don't want to have to resolve the inner reactive stream and then the outer one. I would rather just get a view of the inner reactive streams and let the framework handle that for me. So this is where flat map comes in. What we want to do is to flatten those inner reactive streams, very much like the curve. So we use flat map, right? So flat map unpacks or resolves those inner reactive streams for us. And what we get is actually just a flux of reservations. So these are the saved reservations. Now, that said, if I were to run this code up until this point and put a breakpoint in there and then check the database, there's nothing there. There's nothing in the database because nothing is executed because I haven't subscribed. Remember, these reactive streams require you to subscribe. You need to actually invoke the reactive stream in order for anything to happen. Think of this as a pipeline that you've connected. You've got a number of different pipes through which water will eventually flow, but you haven't turned on the faucet. And so there is no water yet, right? In order to turn on the faucet, you have to subscribe. Okay, so I've got a pipeline. I like to write these things a little bit more concisely rather than tease them out into individual constituent steps as I did there. I like to use individual steps like so. And there you go, names. Okay. So I'm going to visit each name, visit each record, turn it into a stream. Now, that said, if I were to run the code, I would have 8 records in the database the first time, 16 the second time, 24 the third time, and so on. So what I actually want to do is I want to say, first of all, this dot reservation repository dot delete all, and then names, and then find all the data. So what I'm doing is I'm deleting everything first to clear the database rather than having duplicate data. Then I'm writing the data. And then once all that's finished, and only then I'm finding all the records, and then I'm writing them out. I'm logging them out here with print line, or rather, I'm going to log them out here with the logger, which I'll use Lombok to synthesize. Okay, so log info, and voila. Okay, so there I've actually got several different steps, which are again asynchronous, right? They're happening at different times. The delete all returns a mono of void. So I don't know when it's going to finish, but it'll finish in the future. And so I want to make sure that whenever it finishes, on a possible, very possibly on a different thread at some point in the future, whenever that finishes, then and only then do I want to actually write the data to the database. And then and only then do I want to then find all the records in the database and then log them out. This is a very natural thing to want to do, is to be able to deterministically order things in a line kind of like that. So what we've done here is we've gotten that same deterministic behavior by using operators. Now keep in mind, there is absolutely no guarantee that this doesn't happen on a completely different thread than this one or this one, right? But we don't have to worry about that. We can use the operators in the API to write that code and be assured it's going to do the thing we expect it to do. Okay, so let's run it. Okay, so there's our application. It started up, it spoke to MongoDB, it took each record, round trip the record, went to MongoDB, got an instance back. I can confirm as much here, db.reservation.find, there we go, paste, etc. So you can see the record there, Olga, right? There's the individual record. There's the ID. So it worked, right? We got the ID from there. We've round tripped and we talked to a NoSQL data store like MongoDB. That said, there's a lot of different options here. We just used one. You could as easily use Azure Cosmos DB, Google Cloud's Firestore and Spanner. You could use Cassandra. You could use Redis, Neo4j, Couchbase, Elasticsearch, etc. And that's just in the NoSQL. That's just in the NoSQL column, right? There's also the SQL column, and that to support that, we have something called R2DBC. Now, R2DBC is an abstraction that we originated, but which has become a community standard. And here we've got a number of different dependencies here. So we're going to bring in R2DBC PostgreSQL. We're going to bring in Spring Boot Starter Data R2DBC, and I'm going to comment out MongoDB. And that's going to require, of course, some code changes because MongoDB and my SQL database are not the same thing. So we go back to the build, force the re-import of the dependencies. That no longer works. And of course, my data store is a little bit different, my data model. So instead of a UUID, which makes a lot of sense in a NoSQL data store, we're going to bring in a primary key for a monotonically incrementing primary key. And get rid of the import there. Okay, so that done. I also need to specify a connection string. So I'm going to go to properties, spring.r2dbc dot URL, and it'll be r2dbc Postgres localhost orders, and the username is orders. Now, obviously, you shouldn't store usernames and passwords like this in your configuration files. And so if you want to know more about how to avoid that and how to take advantage of the Spring environment abstraction and centralized configuration tools like Spring Cloud Config Server and more, then tune in tomorrow for my Spring Tips session. But for now, just take my word when I say hard coding usernames and passwords and locator credentials and URIs like that in your application files, which will be checked into version control, is a terrible idea. Okay. Now, I'm going to go ahead and restart, having done all that hard work. Oh, connection refused. That's not great. What could that be about? Okay, let's see. Did I? Nope. Brew services, PostgreSQL start. Please work. Well, that's not great at all. Brew services start. Oh, okay, I've seen this issue before. Cat that file. Go to the logs. Maybe it's this one. Okay, so we're going to go here. Postmaster PID, user local var Postgres, cd user local var Postgres, rm postmaster dot pid. You know what? Never rm stuff. Desktop. Okay. Brew services. Okay, fingers crossed. Brew services. PSQL U orders. Okay, now we're cooking. So let's go ahead and restart this. There we are. There's our data store. There's our data. It's gone to the data store. It's come back with monotonically incrementing primary keys. You can see that reflected here. So if I grab the ID 1705 and I go to here, I say select all from reservation. And then, of course, oh, that's not it. Let's see. There you go. 1705 Isilia. Okay. So we're now able to write to a SQL data store and to an NoSQL data store. We can even do transactions, right? This is a common thing. Is suppose I've got data access operations and I want to then, batch some of those things together. I want to atomically do a bunch of things or not do those things. And I can do that with the transaction support in Spring. To support that, I've got the Reactive Transaction Manager. Now, the Reactive Transaction Manager is a variation sort of the interface for the Platform Transaction Manager. In order to use it, basically your surface area, your API surface area is exactly as it was before at transactional. And then in this case, when you do something that's transactional, it has to be public, and then the thing that you do has to return something. So even if it's void, right, like mono of void, it has to be, due in a transaction. And that method will be enveloped in a transaction, and as long as you return the stream that you want to be inside of a transaction, that'll work. I'm not gonna spend time showing you that, but I do want to explain a couple things here. The reason that that's important, the reason that you should know that is because it raises a very obvious question, which is how? How does it do that? Think about what I just said earlier. Everything could jump from one thread to another. The flow of execution could very easily jump from one thread to another. How can that work in the old world where when we did transactions, we did it through storage, right? We had some sort of storage that was associated with the current ongoing transaction that we would then use to either commit the transaction when we're done or roll it back. In order to do that, we need to be able to resolve that transaction. And this is where we get into some trouble, right? This is where we have an issue because the storage that we have for the traditional approach to building services assumes a thread local, right? That thread local stores the current ongoing transaction, and then assuming that transaction commits, we find the thread local, we get the current instance of the ongoing transaction, commit it or roll it back, and then we clear it, right? That doesn't work anymore, right? That doesn't work in this new world where the flow of execution could very easily jump from one thread to another. Thread locals no longer make a lot of sense. So to support that, we have an abstraction called a context, a subscriber context. So we can say subscriber context of, and then it's just arbitrary keys and values, right? Key 1, 2, etc. Right? These keys and values are they're just a way of storing data, right? They're a way of providing data that gets propagated for the life of the application. Very, very convenient, very, very useful thing. Okay, so we've got a context. The context is there. You can use it as a replacement for a thread local wherever that use case might arrive, but you don't need to, because by default, most of the use cases for which you might have that use case are already addressed, right? So for example, declarative transaction demarcation, distributed tracing with Spring Cloud Sleuth, security and authenticated principal, propagation with Spring Security, all these things that you can imagine might require a thread local. We already do that for you. It just works. So you'll see that things like @transactional just do the right thing, assuming you understand that in this case, it has to return a publisher. So we've got data in the database, we've got SQL and NoSQL support, we've got transaction support. A natural next thing might be to build an HTTP endpoint. So I can build a reservation HTTP controller at git mapping /reservations, a publisher of reservation. And I'm going to inject my repository here, my collaborating object, my repository. And we'll use the required args constructor. We'll say return this .reservation repository .find all. Okay, there you go. So there's the find all. That works just fine. This is very similar. If you've ever used Spring MVC, this looks virtually identical. And indeed, those are exactly the same annotations as in Spring MVC. That said, we're not using Spring MVC. This is actually a completely different web runtime called Spring WebFlux, and we're not using the servlet specification, we're using Netty. And so we're in a slightly different world here. Things are a little bit different. I like this style of building controllers where you have a class and then you have collaborating objects injected through the constructor, and you have methods that respond. There's a controller handler methods and so on. There's also a different style called a functional reactive style. So you say router function server response HTTP return route, okay, dot build dot, and here I'm going to just do a HTTP get as before, reservations, new handler function, and we're going to use the reservation repository there. So rr server response dot okay dot body, okay, rr dot find all, and there we go. So there's our rewritten HTTP endpoint. The reason I had to comment out the other one is because these both map to the same HTTP URL, but otherwise there's no reason you can't have two different types. You can have the functional reactive style and the Spring MVC style in the same code base. There's nothing inherent in the component model that precludes that. Okay, so there's my updated HTTP endpoint. You can see it's a lot more concise, right? And actually, this is a builder API, so I can actually chain these things together as well. It's just I can do for loops and if and else and whatever, right? I can do all that kind of dynamic configuration. Build the application, go to the browser, localhost, reservations, and voila, there's our records, right? Okay, so that's working just fine. We've got an HTTP endpoint, and I can hear you collectively shrug. So what? Who cares? I could have built an application that talks to a SQL database and that builds and that returns 8 records in a JSON response yesterday. I don't need reactive APIs to do that. And to that I say, yeah, fair point. You're absolutely right. Thus far, I haven't shown you anything novel yet. What I've hopefully done is persuade you of the fact that when you write reactive code, you're not writing more code and it's not more difficult. And in fact, if you'll indulge me, I actually hope you'll understand or appreciate that writing reactive code is actually simpler than what you were doing before, even though you get much better results. And what I mean by that is amortized over all the possible applications of reactive APIs, your life is much easier for reactive APIs. So without reactive APIs, suppose you want to do server-side events. That's an SSE emitter. That's a different API. What if you want to do JMS? We have to use a JMS message listener container, which is very different from a RabbitMQ message listener container, which is very different from a Rabbit, from a Kafka message listener container, which is very different from returning records from a JSON endpoint, an HTTP application JSON endpoint, which is very different from doing WebSockets, which is very different from any other thing you can think of that's asynchronous, okay? And so you have to learn all those different APIs and you have to learn how to describe them, these asynchronous things. There's, be it threads or callables or whatever. I mean, there's just different ways of saying, hey, I'm going to emit records asynchronously. And each API has a different way of emitting and a different way of consuming, and they're not compatible. So you have to learn all of them in order to be able to do all these things that we all do when we write software. Well, when you learn reactive APIs, that's it. You've got one kind of stuff. You've got reactive streams. If you understand those types and you understand specialized types like Flux and Mono, you're done. That's it. That gets you what you need, as you're going to see for the balance of our time together, to be able to use all these different APIs, right? That's the only thing you need to learn. And there's a nice impact there. There's a really nice fallout consequence of that, which is that I can now compose and integrate to otherwise disparate data streams. I can take data from a WebSocket feed and another stream of data from a Kafka broker, and I can stream both of them together. I can aggregate them. I can filter them together. I can do all sorts of things, right? I can mix them up if I want to. And it's very natural to do that. And there's no glue code. I'm not adapting one asynchronous component model with yet another one, trying to get one to act in the same way or consistently as the other. It's super easy to do now. So actually, while I can see that there's a bit of an upfront learning cost, associated with the learning of these reactive streams types, again, once you've gotten the hang of those very simple types, it's very easy, and now things become much more consistent. Okay, so I actually quite like the reactive streams types, and you can see that from a code perspective, we haven't spent all that much more lines of code, if at all, to do what we're trying to do. So again, here's this is a repository that I created to initialize data. I would have written something like that were I to use Spring Data JPA, right? Any other non-reactive API. Here's the actual API. This is what my reactive application stem to stern looks like, right? I've got a HTTP endpoint, I've got a repository, I've got a model. And we're talking about a few dozen lines of code, including imports, including the public static void main, class and the method there, right? It's just nothing. It's so trivial to get that working. So cognitively, this is not more difficult than using the Java 8 Streams API. In terms of lines of code, it's definitely not more than what we would have done before. And as you're going to see, it's actually because of the consistency and because of the conciseness of that API, it's actually less difficult cognitively, and it's actually less lines of code than what we would have done before. And we're getting the best result possible. This application is the most scalable incarnation of this kind of application. In terms of, I want to write an application that talks to a SQL database and then returns application JSON, this is the most efficient way to do that. I will be able to handle a good deal, many more requests with this code base than I would have were I to use something like JDBC and the Servlet API, okay? All right, so we've got now an application talking to the database. What I want to do is take a look at some of these cases where reactive programming really comes into its own, okay, as opposed to just where we've achieved parity, which I which I believe and I hope that you're so far thusly persuaded is the case. What we want to do is figure out why this thing is unhappy. Compile, please. Computer, compile yourself. I see an error. Could it be just this? Yeah, okay, it's trying to tell me about something that isn't so. All right, so I've got my service. Let's now take a look at some of these cases for which reactive programming is not just equal to the task, it's better. Reactive programming really comes into its own whenever you have a use case where you might have otherwise traditionally monopolized a thread. So suppose you're building something that requires liveliness, such as a chat or a stock ticker or presence tele-notifications or anything where you want to have liveliness, up to date, constantly up to date results, right? You don't want the implied lag in a chat when you're talking to somebody if the client has to wait 30 seconds and then poll the service for new messages, right? It's much better to stay connected and just get the new data and communicate that back to the client immediately. So this is a great use case here, right? Think about that traditional approach. You'd have a server socket parked on some port. You'd have a client that's consuming that, and the server socket is using a Java IO input stream, and that, of course, is a blocking API. Java IO input stream, where you say input stream.read, and you read the data that comes out of the read method when the data is available, but no sooner. So while you're waiting for that next bit of data, the next byte, what are you doing? Well, you're blocking. The thread of execution on which you made that call cannot proceed unless that method returns or you interrupt it. There's no other way out of there. And this is the problem, right? We're blocking, we're waiting for data that may or may not arrive, and we're sitting on a thread, and that thread is no longer accessible or available to anything else in the system. This is where we get into trouble. So what we want to do is not block. We want to jump off the thread and make it available to other things in the system wherever possible. So what we're going to do is to use reactive APIs. That has the effect of decoupling the link between the number of requests I'm handling and the number of threads that are being used to handle them, right? And so one example of a non-blocking, asynchronous, lively kind of stream is WebSockets. So what I'm going to do is I'm going to create a service that creates a infinite stream of greetings, and we're going to use the WebSocket API here to demonstrate that. So we're going to create a greeting service that will return a stream of greetings response given a greetings request. Okay, and obviously these two types need to be defined. Alrighty, class, here we go. So it's a response. The response has a string message. The request has a name, and given a name, I'm going to return a stream of responses. So at data, at all-args constructor, at no-args constructor. These are just details after all, so I'll just expand them out a little bit like that. And I'm going to then create a reactive stream. I'll say return publisher of from the stream, and I'll use the stream generate sub operator here. This is Java 8 stream that I'm adapting. create a new greetings response. Hello, request.getName at instant dot now. Okay. Good. Replace with a lambda. Delay elements, duration of seconds. All right, so there's my infinite stream. What I'm doing is I'm creating an infinite stream of values, but of course, in order to demonstrate that, I would want to print it out. I would want to print out each value that we received, and if it just kept on going at an infinite speed, it would just very quickly scroll down to the floor and out the door. So what I want to do is I want to make sure that I stagger the results a little bit there by a second, and then I need to turn this into a WebSocket endpoint. And here, I need to write a little bit of code. I need to write a WebSocket handler. So I'm going to create a WebSocket configuration class. And the WebSocket configuration class has to do a few things. First and foremost of which is we have to map our WebSocket endpoint to a HTTP and upgrade URL. So WS greetings, and I'll use the WebSocket handler, WSH, and 10. Good. So what I'm doing is I'm telling the web framework, Spring WebFlex, I'm saying, when somebody goes to ws/greetings, an HTTP URL, upgrade them to the WebSocket protocol and give them access to the WebSocket business logic that's epitomized by the WebSocket handler there. That's where our business logic, the actual business of doing WebSockets, will happen. And we're gonna look at that in just a second. But in order for Spring to know about WebSocket handlers, you need to register a WebSocket handler adapter. Okay, so WebSocket handler adapter. There you go. So in order for this to work, we need to inject our collaborating object there, the greetings service. Okay, and we're going to then make a call to the downstream service. We're going to say that when the incoming client connects to the service, we're going to have a new WebSocket session established. I can say session.receive, and that'll give me a publisher of WebSocket message. And I can take the WebSocket message, and I can get the data here. The payload is text, and that's going to be the name. All right, the client's going to send us a name. We're going to send back a stream of greetings. So I would take each name and turn it into a new greetings request, like so. I'm going to take each one of those names, gr, and I'll turn it into a call to the greeting service. Well, of course, that's going to return a reactive stream. So again, same problem as before. I want a flat map. I'll say greeting service dot greet gr, right? Same as before. And that done, I'll need to map gr. I'll map each response into what? I want to take each response and get out the constituent text of the message, like so. And then for each one of those, I'm going to take each text message and turn it into a WebSocket session text message. Okay, so I'll say text. And that's it. That's the entire pipeline. That's the entire conversation. And again, I'm just using these reactive APIs, and I just send that back to the client, right? So session.send socket message flux, and there you go, right? And of course, this boils down into a lambda. There we go. And that's it. So now I want to demonstrate this. I want you to see how this is working. And I couldn't think of a more expeditious way forward, my friends. I'm afraid I'm going to have to do something I'm not proud of, something that I would not otherwise do in polite company. I'm going to write JavaScript. So I'm going to go here and create a new directory, source main resources static. Create a new file, ws.html. And here, I'm just going to create a little HTML page, script, window.add event listener, and I'm going to listen for an event. The event is going to be the load callback, and I'll create a WebSocket object, localhost /ws greetings, ws.add event listener, message, come on. And here, I'm also going to listen for the live socket to be ready. I'll say add event listener open. And so when the socket is open, I'll send a name, Paul. Okay. Then I'll log out the results. So I get results in the on message callback message console.log message.data. There you go. So I'm going to use that. That'll be my callback. I'll go ahead and restart the application, and we can now visit that page in the browser, localhost ws.html. Okay, Command-Shift-I, and there you go. You can see it's going to produce a never-ending stream of responses every second. In perpetuity, it's going to produce new results, and that's okay, because in between the raindrops, in between each emitted value, it's not blocking. It's not keeping a thread open. It's freeing that thread up for something else in the system to be able to better repurpose it. And that's where reactive programming really comes into its own. That's where we get benefits that you would not otherwise get. Much better scalability. The goal here is not to make, well, all right. The goal here is not to make each individual transaction faster. And indeed, paradoxically, these transactions, each individual transaction might be the smallest bit slower, because there is, in this case, the possibility of thread context switching, right? So you might have to contend with that. But we can handle a lot more transactions, because we're never, ever sitting on the thread wasting time. We're never, ever sitting on the thread wasting time waiting for something to happen. And that's where we get a huge benefit out of this, right? Is we have the ability to write code that frees up the thread. Now, of course, it's very important that we never, ever block when we're doing something on a reactive pipeline. If we use these reactive pipelines and we end up blocking, we get into trouble, right? And so earlier you saw me stagger the results of these responses by delaying the elements. I can do that because I have behind the scenes a thing called a scheduler. The scheduler is the thing that actually, schedules the movement of execution, the movement of each reactive pipeline step onto a thread. And that scheduler is 1/2 timekeeper and 1/2 thread pool. Okay, so you don't normally have to worry about that. You don't normally have to work with that, but you can, right? You can actually say subscribe on schedulers dot whatever, and I can provide my own executor, right? Like so, or I can just use one of the default values. Subscribe on schedulers dot elastic, right, or immediate, right? If I want to run the reactive pipeline in the same thread as the client, then I can use that. That's basically synchronous. You're not using a thread at all in that case. Parallel, bound, elastic, etc. So if you were to do something on a thread that should not be blocking, like this one, you could cause some real trouble, because remember, we don't need a lot of threads now, right? In fact, by default, your reactive application only creates as many threads as you have cores in your CPU. So if you have 4 cores, then your Spring application only has 4 threads, right? Your web front end here, your reactive web front end only has 4 threads for scheduler, right? That's okay, because each time you're using a thread, you're not blocking, so you're only doing what's required to ask for the data or to then process the data. You're not waiting for the data. Processing data is super fast. Waiting for data that might be crawling its way across the internet, that's going to take forever. So you avoid that by backgrounding, right? The runtime actually, you write your code in such a way that you say, I'm asking for the data. It's not here right now, so here you can use my thread, and when the data comes back, I'll get a callback and interrupt that'll allow me to then resume processing the data. And in the meantime, I don't need this thread. That arrangement works just fine, so long as I just said, as you don't block that thread. So it's very important that you never, ever block a thread. To help you ferret out any accidentally blocking code, we've created a Java agent here called blockhound. Now, blockhound is trivial. You just add it to the class path, and then you say blockhound.install, and then should you do anything silly like thread.sleep, you'll be rewarded with a blocking operation error, which will show you the errors, the thing that you did that actually caused the thread to block. And very important, right? Because again, if you've only got 4 threads and you block on one of them, you're not blocking one user, you're blocking 25% of your users, right? Very, very important that you never block. So as long as you're willing to do that, as long as you're able to do that, you can. And by the way, you can have blocking interactions, right? It's still Java. There's nothing technically wrong with that. It's just that you need to remember to, as I say, subscribe on a different thread pool, right? Make sure you do that work somewhere else. Don't do it on a blocking thread pool. All right, so we've got a service. It's up and running. Let's build a client. Let's build something to talk to that. So we're going to go back to starts.spring.io. Here, I'll build something imaginatively enough called a client. I'll use Java 14. I'll use Lombok, the Spring Security support, Reactive Web support, RSocket support. And I think that's it. I think that's all I really need for now. Yeah, okay, sure, let's do that. So we're gonna hit generate.
Start.spring.io.
All right, so we have an application. We're gonna open it up here and comment out the bits that we don't need just yet. Actually, we can leave them all in because in this case, we're gonna act merely as a client to the downstream service. We're not actually a service in of ourselves. We could be, in which case, you can imagine we would be maybe an API adapter, an API gateway, something that responds to requests from the outside world and then forwards them, adapts them, transforms them in some way to the downstream, fairly, assumedly otherwise homogeneous set of microservices downstream. A very common use case, and you might even use or involve Spring Cloud Gateway. Now, Spring Cloud Gateway is a reactive API gateway that we built. You can use that. Really, really nice micro proxy. That's a natural thing. I've even covered that in Spring Tips videos and other versions of this talk, but we just don't have enough time today. So I'm going to make sure we, I want you to find out about that, but we don't have time for that this time. Okay. So what we're going to do is we're going to act as a client. We're going to say I want to be an HTTP client. And I'm going to create a bean. Actually, you know what? I might even do it differently. Let's do that here. I'll create an application listener. Application ready event. HTTP. New application listener. And okay. So in order to make this, we're going to act as a client to our downstream service. In order to do that, we need a reactive HTTP client. So I'm going to use the web client. The web client is a non-blocking HTTP client. So there's no blocking threads in the client side. It doesn't matter if the server side is reactive or not, right? It's HTTP. HTTP doesn't understand back pressure. It doesn't have the ability to tell us whether it's overwhelmed or not. But so I can use the reactive non-blocking client to call any web endpoint, any HTTP endpoint. It doesn't have to be reactive web or anything like that. So I'll use the web client builder. I'll say builder.connect. Builder.build, and there you go, right? I'm just using the builder to configure it. I can configure things like filters here, and we're going to talk about that in just a bit. But for now, I've got a reactive non-blocking client. I'm going to use that to make a call to the downstream microservice, okay? So http.get.uri, http localhost 8080/reservations .retrieve.body2flux. And what I want to do is I want to take the data that comes back, that's going to be JSON, as you know, and I'm going to turn it into a stream of reservations. So I'm going to go back to here. I'm going to do something terrible, something that you should never, ever do, ever, not even when you're all by yourself at home and no one is looking. I'm going to copy and paste code. So I'll go here, paste that into my application, and get rid of the qualifier annotation there, the annotation for the ID. Okay, there's my details, my client-side representations of these of the JSON data. I'm going to map it to a reservation like so. I'm going to map each reservation to a name, and I'll take each one of those, and then I can just subscribe, I guess. I mean, let's just log it out. So I'll create a logger here. All right. Okay, so good stuff. We can run it. Alrighty, good, run. Oh, I can't start up on that port. Sure. Okay, server.port equals 0. Restart. Okay, there we go. There's our data. It worked, right? And we called the downstream service. We got the reactive stream of results back. But keep in mind, this isn't truly reactive, right? We're making a call to HTTP endpoint. It doesn't matter how that HTTP endpoint is implemented. From a reactive streams protocol, this is insufficient. It's not really as rich as we would possibly hope for, but we have the best result that we can given the fact that we're using HTTP. I'm making a call to the downstream service. The downstream service is written using Spring WebFlex. Spring WebFlex in turn has some smarts in there where if a client disconnects, the WebFlex service will perceive that disconnect and it'll stop streaming whatever it was streaming to send the response back to the client. So it'll apply back pressure to itself. And from the perspective of the client, it can then disconnect and we won't waste any resources. So it's not bad. It's just not as nice as it could be if we truly understood back pressure. That is to say, wouldn't it be nice to be able to make a request 10 more records, and then not do anything for an hour, and then request 10 more and have that work, right? You can't really do that with HTTP. Either you've connected or you've not, right? But this does work, right? Now we have a simple client. We're talking to a downstream service. We've got a simple HTTP interaction. What we're going to talk about in just a second here are some patterns for handling some of the volatility that's implied in that call. But that said, I want to just briefly make sure I answer any questions. So I'm going to stop sharing my screen so I can look at the Q&A. Don't worry though, nothing's wrong. I'm still here. Let's just make sure there's no questions from the Q&A panels. I don't even know where I'm supposed to find that. Q&A, there it is, 4. Would Resilience for J work with Reactive? If not, yes, exactly. So Resilience for J does work with Reactive, and you could have gone to start.spring.io and chosen Resilience for J, and you can use the Spring Cloud circuit breaker abstraction. And I even did a Spring Tips video on that, right? And I would have alluded to that later. We're building an MVP-based architecture with microservices. Initially, we have 4 to 5 Spring Boot apps, and they have to communicate to each other via HTTP. Is it advisable to use reactive APIs, e.g. web client, instead of the traditional REST template for their communication? Yes, yeah, absolutely. Even if your services aren't using reactive, even if they're not using Spring WebFlex, and they should, but even if they're not, using the web client is a win. And actually, you can use, we support returning publishers from Spring MVC controller methods now, right? Just so that you can do reactive web client kinds of service orchestration and composition, and then return that from a controller handler method in Spring MVC, not Spring WebFlex. I mean, Tomcat, right? Spring MVC and Tomcat, because that web client is way better. It's a way better choice, as we're going to see in just a second here. Can we move our API to WebFlex without impacting a client? Yeah, of course. Again, the client doesn't see anything besides the fact that it's HTTP. So your HTTP response is exactly as it was before. Why use Lombok with Java 14? So I did why use records? Why not use records with Java 14? No reason. I actually did a great Spring. Well, you can tell me. I did a Spring Tips video on the great Java 14 release that it came out just in time for Java 14. I don't. Somebody just asked. We can't see my screen anymore. Yes, that's correct. I'm answering questions. I'll be.
Yeah, if you wanna put your camera on so they know that you're.
Oh yeah.
I'm
still there. Still here, friends. Don't worry. Okay. So why not use Java 14? You absolutely could. I did a Spring Tips video on it. I think Java 14 is super compelling. I love Java 14. The records features are preview features. So you have to do -- enable preview, and it's just a little bit more setup than I like to do for my demos. That's all. I will definitely be using Java 14 as soon as it's GA, and I've already used it for my own code a number of different places. Does Netty Server support the concept of a context? I think so. Yeah. Somebody asked, does Feign client work with WebFlex? Great question. No, not yet, right? So Feign itself, Open Feign, there's no reactive support, right? It's very important that whatever we do supports reactive APIs natively. It has to support native APIs, and so we can't just take an existing non-reactive, blocking API and turn it into a reactive non-blocking API. We can go the other way around. If you have a non-blocking reactive API, we can pretend to be a synchronous and blocking API as opposed to an asynchronous non-blocking API, but we can't take a non-blocking API. We can't take a blocking API and turn it into an asynchronous one. So my understanding is that OpenFeign are looking at that, but they're not there yet, right? And that'd be cool. Will you be able to watch this outstanding presentation on YouTube, Bob and Paul, friends?
Yes, we'll send a link. It'll take a couple days for the Zoom to all get compiled and uploaded to YouTube and blah, blah, blah. But yes, this will definitely be made available for a later date so people can come back and double check their work.
Groovy. Okay. Yeah, so good. Thank you. All right, so let's get back to it. I just wanted to make sure I cleared the questions.
And thank you for that. Yvonne was also saying thank you because there's some really great questions, but he wanted to make sure that they got the expert answers, and you, my friend, are the expert answer.
I have the T-shirt. That's about it. Well, oops, one more question. Somebody's asking about, what is the best way to design and scale reactive applications that are not based on request response? There are many reactive streams that are continuously pulling data from external sources using reactive web client. Think reactive Kafka Connect or crawler. Most of these streams are unbounded and never stop. That's exactly the use case. I even demonstrated that, right? I even demonstrated that with the never-ending greetings response thing. Reactive APIs are the best way to do it. You use the same API as you would when you're not doing unbounded things like that. Where can you get the T-shirt? Well, this is the cover of my Reactive Spring book, so it's just a custom thing. We used to have a store.spring.io. That would be nice to have back. Another question is, where do I get tips on Spring and GraalVM? Check out my video, the Spring Tips video, Spring and GraalVM Part 2. It just went out a few weeks ago. Next question. In Project Reactor, how can you get a hold of subscription in a pipeline, for example, in a map operator? You mean you want to get access to you can get access to it in the do on next or do on each. I'm not sure which one it is. I think you can get it from there. So I don't know offhand. Can you use reactive stuff and Spring MVC Tomcat based? Yes. Yeah, of course. Like I said, Spring MVC has some special support for non-blocking reactive pipelines. I still recommend using Netty if you can, but if you already have existing code that's based on Apache Tomcat, you can actually start writing reactive controller handler methods that return publishers, and that will work in the same way that you can return a completable future from a Spring MVC controller handler method, and that works today and yesterday, right? Okay. Is there a filter registration bean counterpart in Reactive to register filter based on URL patterns? You have to do a filter. There's a different filter API. It's actually a little different. Well, Webflex eventually replace Spring MVC. We're not deprecating anything, but for my purposes, I start all my code as Spring Webflex, and rarely do I need to use Spring MVC anymore, right? But that said, there's still a feature gap, right? Spring MVC has been around for 18 years and Spring Webflex for 3, as GA technology. So you might have use cases for which Spring MVC is better, and that's why it's not going away. We would like to fill in the gaps. We'd like for that gap to be nil, but who knows? Yes, you can adopt existing non-reactive APIs. If you have anything that's asynchronous, can be easily adapted into a reactive API using operators like flex.create or flex.generate, right? So that's a whole other thing, and I've done, you can Google that, flex.create, okay? There you go. Actually, there's 2 questions about how to adopt non-blocking APIs, or how to adopt reactive APIs to blocking APIs. So those are both answered there. If we have an existing application using Spring Web and want to migrate it to Spring Webflex, which underlying server will serve the application? If you're using Spring Webflex by default, if you go to start.spring.io and bring in Spring Boot Starter Web Reactive, I think, or something like that, you get Netty. But you can use Tomcat, right? You can use Netty, you can use Jetty, you can use Tomcat or Undertow, right? It's just not going to be full end-to-end reactive. There's certain parts of the servlet API that are fundamentally blocking. But yeah, you can do that, right? Does Spring Reflex remain relevant after the arrival of Project Loom and virtual threads? Yes, yeah, of course. So Project Loom is great. It makes it so that we can have a cheaper thread, and that means that we can have more threads in the thread pool. But we still have the data flow problem. How do we, as we're about to see, how do you compose and integrate disparate streams of data, first of all, and then also, how do I work with it? How do I apply back pressure? All these things are not implied in traditional APIs. So yeah, I'm welcoming Loom. I cannot wait for it to arrive. We will certainly have a Loom-based scheduler or something like that. But yeah, it's going to be a great win for everybody to have that. Okay, my friends, let's get back to it. So stop video, share screen. Okay, so now I've made this network call across the wire. I got an HTTP GET response, and I'm assuming that downstream service is always going to be available. That is not necessarily the case, right? We don't know that service will always be available. It could fail, and so I want to make sure that when it fails, if it fails, that I do the right thing. So I can actually have an on error resume. I can say exception flux.just, and so when an error happens, I can provide a default value, right? I can also say I want to retry. I can retry 10 times. I can retry when a certain predicate applies, so retry.when, right? Okay, I can retry 10 times, and I can back off a little bit longer. So I have a lot of operators here that I can use. I can also use a timeout. I can use a timeout. I can say timeout.of seconds 1, and I can wait a little bit longer, right? So lots of different operators that get built in out of the box just by using reactive types. These are not part of the web client, they're just part of Reactor. Remember, I'm using just a regular flux, right? I have just a flux up until this point. So the return value of that is flux. There's nothing special here. There's nothing, you could do this with any reactive stream. And that's really nice. You've got these operators that give you the ability to control how you fail, if you fail. And then I can subscribe. Now this timeout thing, let's talk about timeouts here for a second. Timeouts are a very common use case because they're usually used to enforce SLAs. I have a client that's depending on me to return a response in 5 seconds or whatever, 5 milliseconds, it's your call, right? Arbitrary number here. And the downstream service makes it, I'm depending on yet another service. That downstream service might respond in, if I have to respond, let's say for simple math, in 10 seconds, the service on which I depend needs to get back to me in 5 seconds. That way, even if it fails, I can retry one more time. So I use a timeout. I say, okay, you have to return a value in 5 seconds. Well, that's unfair, right? What if that thing in turn needs to transitively call yet another service? Okay, so that other service now needs to respond in what? 2.5 seconds for the same reason, right? It needs to finish within half of the allotted time of the caller, so that should that downstream thing fail, the caller can retry the request and still make its SLA. And so you can see that this becomes a very precarious position. It's untenable because as we move further away from the origin of the request, we are decaying very, very quickly, right? At first it's 10 seconds, then 5, then 2.5, and so on. And eventually, a few hops away are the services that are, the poor services that are required to respond to that request they're given virtually no time at all to respond. So timeouts are unfair. They don't actually solve the problem particularly well. And there are alternatives, so that it's not even really a requirement. What we want is to get a response within a certain amount of time. Timeouts don't guarantee that. They just mean that we get one bite of the apple. We can try one more time after we failed, right? But there are other alternatives to guarantee that we get a response within time. One very common pattern is called hedging, right? Hedging in English means to hedge your bets. So it's good advice. You don't invest in the stock market, and you don't put all your money into one stock. You hedge your bets by diversifying the risk and investing in multiple stocks. You don't put all your eggs in one basket. We've all heard that common aphorism. There's a lot of examples of this in English, right? You don't put all your money on red in the casino. So the idea is very simple. Don't put all of your options, don't bet everything on one thing. Same thing here. Why are we betting everything on this one service? Why not just assume that something might fail and launch the same request as configured here, right? Remember, that's just a publisher, and here I'm subscribing, right? But remember what I said earlier, I'm defining a pipeline. I can define as many pipelines as I want. Nothing is happening yet. So if I were to have, let's say I have multiple pipelines, right? Publisher, and each pipeline represents a call to a different host and port, right? This is host 1. Here's host 2, right? and here's host 3. And again, each one of these I'm using null, but just imagine I copied and pasted this and I swapped out the host and the port. Okay, so it's exactly the same network call. I'm defining all 3 of them exactly the same. And because at this point I haven't subscribed to any of them, there is no network traffic, right? All I'm doing is defining a Java object. This doesn't mean anything has happened over the wire yet. I have to subscribe. And right now, this is assembly time. It's not execution time. There's a difference there, right? I can do whatever I want at assembly time. I can rewire or reconnect those pipes in whatever formation I want, and then I turn on the faucet, and then the water flows. So right now I've got a bunch of pipes. I can then change that arrangement going further. One of the things I can do is to use a pattern called hedging. Hedging is a very simple idea. You make the same request, identically configured, identical request to n instances of the service, right? Where n is any arbitrary number greater than 1, right? So I'm making a call to host 1, 2, and 3, for example. Maybe I have 10 instances of the service. Maybe I use my Spring Cloud Discovery client to resolve all the instances of that service in the service registry, and then I make the call to the downstream service. I don't use all 10 instances. I just pick a subset, right? Because I'm assured that if one of them fails, surely not all 3 of them will fail, right? So I want to have one. I want to guarantee that at least one responds in time. And remember, services will fail. It's just table stakes for building software on the open web. Things are going to fail on the internet. That's just it's a fact. On the internet, nobody can hear your services fail. So what we want to do is we want to make sure that when we make that downstream call, that we don't assume that it's always going to work. That's a fool's errand, right? It's not going to, it's always going to, there's always a possibility of failure. Things will break, right? And high performing websites assume as much. So this hedging pattern is a very simple pattern because and we know about it because it's being used at high performance websites like Google, like Netflix, and like Uber, who have all talked about the use of hedging in their services because they all want to make sure that they get a response within time. So the idea is I make a call to I make 3 identical calls or any number of identical calls to the same service deployed across a number of discrete, unique hosts and ports. That way, if one of these hosts and ports fails, surely one of the other ones will work, right? And again, the service could be out to lunch, the network could be down, it could be latency, it could be overwhelmed, who knows, doesn't matter. What I want to do is then pick from among the 3 responses that I get, or perhaps don't get, and pick the first one to respond. So if 2 don't work, if they fail, maybe one of them will work, and that's the one I keep. And that'll be the one that gets me the response within my SLA. And sure, there you can still have a timeout, but you only want to have the timeout after all 3 have failed. So what I want to do is I want to say, let's wait for each one of these to respond. And the first one to start emitting a value, I'll keep that one and I'll apply back pressure to the other 2, right? So this is a very, very natural thing to do, right? But it's very difficult to do, as you can imagine, in threads. You wouldn't want to do this using Java threads. Just imagine the cyclic barriers, the phasers, the countdown latches, the runnables, executor services, executors, etc. that would be involved in that. So instead, I'm going to use this very simple pattern: host 1, host 2, host 3. This is a very nice thing, very easy thing to express in a reactive API. It's kind of like the select function in POSIX, right? File descriptor, etc. So I say first, host 1, host 2, host 3, and I get the first one that returns, I keep that one. That's the result that gets sent back, and the other 2 are automatically canceled. The back pressure is applied. That gets me the result that I want as fast as I can get it. Obviously, this only works if you can afford to make the same network call 3 different times without any undue observable side effects, right? This is to say they have to be idempotent, right? You can't make the same network call. And you shouldn't do this pattern. You shouldn't use this pattern on the charge the customer credit card endpoint. That's not going to be great. Definitely to be avoided, right? Okay, so hedging is a very natural thing to express in reactive APIs. There's a lot of really interesting APIs, a lot of different operators that you should learn about, right? And that make working with disparate streams of data more palatable. These operators are a huge part of the value of using reactive APIs. They make all sorts of service orchestration and composition problems much easier. Another common one is, suppose I wanted to get data from a stream or 2 streams or whatever. So I say stream 1, S1 equals null, blah, and then S2. Okay, so I'm going to say I want a zipper. I want to use I want to get one value from the left side and one value from the right side. So I say flux.zip map, and I'm giving a tuple, and I say get a T1 and then a T2, okay? And then I can say I want to map each one of those strings, and I can log it out, right? I can do whatever I want. So like, that's a very natural thing to do. Imagine I'm calling an order service over here, and I'm calling the product details catalog service over here, right? I can enrich the results for everyone that comes back. I can say, give me all the orders for this guy with these IDs, and then give me the details of that each product at the same time. So again, these reactive streams launch at the same time. They're on different threads. So now I'm getting back both results at the same time, and as one arrives, I pair it up with the resulting, the matching value from the other stream, and then I emit that in toto to the consumer, right? I get a composite stream. Very, very useful API. I ran into a use case the other day that I thought was super interesting. Was I have I'm using a protocol called RSocket. We're going to look at that in just a second. RSocket's bidirectional. So I had a client that was sending me data as I was sending it data. I imagine I am the service, and I'm sending data to the client of my service, but I only want to send that data so long as the client is interested, first of all, and second of all, connected. So I was having the client send me a status, like telemetry information about the client. If the Wi-Fi is laggy, or if it's poor or whatever. And so the way this got modeled is, let's say I have string telemetry, right? Whatever, just it's a stream of data coming in, right? And then I want to return a stream of, let's say, integers, whatever, out, right? I'm using Kotlin there, out. I want to turn a stream of integers out. So I want to keep producing the data for the out, but only as long as there's nothing in this. So telemetry is I'm subscribed to it, but there's nothing being produced until there's an error condition. Then something is produced, right? So it's an empty stream. It's basically for most of the application. Hopefully for every application all the time, my telemetry stream looks like that, right? But we don't know that, right? The stream, I'm subscribed to it, and I'm waiting for feedback. I'm waiting for information. If that information comes and it's bad news, then I need to cancel the production of the out stream, right? So, okay, I've got two streams. One is in, one is out, okay? And I want to say return out, but only so long as telemetry is empty, right? So as soon as telemetry emits a value, then out will stop. And so this is what I return from my WebFlex handler. I say return integer flux, right? Integer flux is the thing that I actually send back, but it's only going to produce new data as long as the incoming data has nothing in it. As soon as there's an error, I get that telemetry information, then we stop producing out. How cool is that? This is a very natural kind of use case, right? A very natural kind of pattern, which is stop this based on that, right? This kind of service orchestration and composition is such a natural part of Reactive APIs, and you can see that this has nothing to do with Spring. It's just Reactor, right? It's ideal for service orchestration and composition. You can't really do this kind of stuff, and certainly not with nearly so concise a code base without Reactive APIs. There's actually even a third-party project that I really quite like called Assembler. It's not my project. It's not our project. It's just a third-party thing that you can use to make short work of the N+1 query problem in multi-database and microservices aggregation space. There's a implementation for Reactor for Spring WebFlex and Reactor. And so the idea is you write a deterministic DSL, you use this DSL to create an assembler of a logical type. And I wish they would change the example here. Transaction, to me, reads like a framework transaction or something, but it's not. When they say transaction in this example, they mean a logical type, like an order or something, your aggregate type, okay? So I'm going to create an assembler of an order or a customer, okay? And then I'm going to use the customer ID as the correlation key, right, for the extractor. And I'm going to define how I get the data. The data comes from the supplier, which is a reactive stream that produces a flux of customers. And then for each customer that I get, then I call get billing info, and I match each result that comes back by matching it against the customer ID. So the customer ID is of the same type as we get from calling customer ID on the customers. And I get a one-to-one relationship for that. This is a mono, presumably. And then I get a list here, and I'm going to actually get all the orders for the customers. And again, I'm matching on the customer ID. And this is a stream, right? A flux of orders. So again, the result is a bunch of transactions that are created by calling transaction.new, whose constituent parts, whose data are informed by these reactive network calls, whose results we correlate by matching against customer ID. So I got a publisher, more than one, right? Potentially more than one order, or in this case, a transaction. And I've got a whole bunch of customers that I'm using to get, so I'm getting all the orders for all the customers. And then for each order, I'm fanning out and I'm getting the billing info and the orders for the customers, right? That's very, very cool. It's very easy to express that, very easy to understand it, but you don't see a single line of threading. You don't see a single line of any of that stuff. I don't have any kind of weird fork joining kind of things going on. It just works, right? It's just 5-6 lines of code, and I've gotten the most efficient version of that code possible. So I love this kind of stuff. Now, thus far, I've showed you HTTP, and I like HTTP, but HTTP is a fairly simple protocol. It has a number of limitations. First of all, no matter what version of HTTP you're using, it's inflexible. It only supports request response. I alluded to something called RSocket, which supports bidirectional communication. Another problem is that HTTP, especially with 1.x, is just not really intended for services, right? It's meant for document retrieval, but it's textual, right? So you need to send base 64 encoded binary data, which is extra computation and extra work. It's inefficient. It's porous on the wire, so it's very heavy. It's as opposed to compressed binary data. It supports only one message exchange pattern, as I said before, request response. So you can't do bidirectional communication. You can't do fire and forget. You can't do anything else. It's just request response. It also requires you to make a connection and then disconnect, and then make another connection and then disconnect and then make another, etc. HTTP 1.x fixed that to some extent because you can now pipeline requests. HTTP 2.0 improved that greatly because you can now multiplex requests, but for most of the history of HTTP, it's just not been particularly great in that respect. Multiplexing is the right solution, right? So yeah, I'm just not a big fan of HTTP as a service mechanism. It works, it's just not the best for that kind of use case, and especially for not high speed kinds of use cases, or for other kinds of message exchange patterns. For example, fire and forget. How do I send a request to an HTTP endpoint and then ignore the response? Just completely ignore it. Just disconnect as soon as the data has left my network, right? My network card. It's just not easy to do. You have to wait for something, even if it's just an empty HTTP 200. So these kinds of patterns, I want to support these kinds of different patterns. And I also want a number of different other benefits. I want something that's stateful. For example, when my client connects to the service, I want them to stay connected. I don't want to have to create the network connection each time and then worry about that network authentication and the ACK and then have to dismantle it all each time. I want to stay connected because it's faster that way. I also want to support any kind of arbitrary data. It can be binary, it could be text, it could be whatever, right? I don't want to have to assume it's all text by default. And so there's a lot of different ways to support something like this besides HTTP, most of which don't support reactive programming. There is a Salesforce contributed an extension to gRPC that allows it to emit, because remember, gRPC is code generation, which I also don't want to do. But Salesforce created an extension to gRPC that generates reactive-based gRPC clients using Project Reactor, no less. So that's interesting if you're using gRPC, but I think we can do better. There's something called RSocket, as I talked to you about earlier. And RSocket, it originated at Netflix. Ben Christensen, one of the people who created RxJava, was at Netflix, and he and others worked on RSocket. They went to Facebook, and that work is continuing there at Facebook to meet the use cases of one of the largest websites on the planet. They built a number of implementations, client bindings, C++, Java, JavaScript. The Java client uses Reactor. So we could use our RSocket directly. It's a very approachable API, even in its raw form. But we've taken that a step further and we've integrated it into Spring. And so now, and by the way, this is one of those places where you want to watch or you'll miss it. Now it's trivial to write reactive RSocket controllers. So I'm going to turn that service in my service into a greetings endpoint. And that's it, friends. That's the entire thing. So I'm going to go here. I'll say our socket server port will be 8888. And we're just going to restart. And now on the client side, I want to consume that data. So let's make sure that this thing has restarted on the service. And I'm going to do the same thing as I did before, but for RSocket. I'm going to create an RSocket client, if you will. But keep in mind, in the RSocket world, there's no client service, because once either side is connected, they're both able to send data to either side at any point that they want, right? So we call it an RSocket responder, or an RSocket requester responder. Okay, so RSocket requester.builder, builder. Either side can be a requester or a responder. That's what I'm trying to say. Okay, so there's no such thing as a pure client service relationship there, or dynamic, as you would with HTTP. Okay, so there's my RSocket requester. I'm going to use that to talk to my RSocket endpoint. Now, I brought back security in the application, but that's not going to work. So let's comment this out just for a second. Okay. All right. Re-imported. Restart. And now, same idea. Okay, RSocket. Okay, so we've got the RSocket endpoint. And what we're going to do is the same idea. We're going to use the RSocket requester to do the work here. The RSocket requester is just a RSocket requester here. Good. RSocket. And turn args. Okay. So RSocket requester dot route. I'm going to make a call to the route. So again, because we connect at the very beginning of the application, I'm already connected. It already knows to what host and port I'm connected. I want to make a call to the route. I want to get some data from it. I'm going to send some data. So data. The data that I'm going to send in is a new greetings request, right? So Spring fans. And the data that I'm going to get back is going to be a stream of greetings responses. And then I'm going to subscribe to it. Actually, I'll map to the message first. So x.get message. Good. And I'm going to log it out. So I've got a logger. Good. All right. There's my updated thing, updated code. Okay. Good. All right, so there's the application. You can see it's going to send a reactive stream of results in perpetuity, just like the WebSocket endpoint. But now I'm talking, service to service, and I'm using RSocket. RSocket understands true back pressure. I can subscribe, get 10 results, and then stop. And then 5 minutes later, I can request more. I can also cancel. I can apply back pressure that way. It's also bidirectional, so both sides can do this. I could actually set up a controller that responds, like when the RSocket requester connects, it can act as a controller and respond to requests that are coming from the service as well. Also, I have some operations friendly features in RSocket that are interesting. One thing that I love is that there's a metadata frame, right? So the RSocket requester, you can see I can call it metadata, right? I don't have, when I say metadata, I mean I can just do metadata. I don't have to have data. I can actually put some data in there and then a MIME type, right? Whatever, right? Something like that. And as long as the other side knows what that metadata looks like and how to read it, it can read it. So I can use this to communicate out of band information, things like my latency, things like my health and my uptime and my metrics. Remember, if you've used Spring Boot's actuator, you're probably familiar with the idea, but this is a very useful thing when you're building services, is to have an out-of-band channel to communicate information about how healthy a service is. So imagine a requester connects to my RSocket service. The RSocket service is overwhelmed. The service can say, hey, if you make a request, I'll do my best, but I'm backlogged. You might try somebody else. There's other nodes in the system. You might want to talk to any of these other nodes, right? That's a very easy thing to do here, to communicate that with the metadata. And there's even a mechanism to propagate metadata to the consumer, the requester, again, as a separate thing. I don't have to make a request to an endpoint to get that data. I can get it as a push notification, basically, right? So I like RSocket. This is using the low-level RSocket API. It's not that bad. That said, my buddy Mario Gray, he is a smart guy, another guy on the Spring developer advocacy team, and he had this idea about doing a Feign-like thing for RSocket. And actually, somebody else asked about HTTP and Feign. And one answer to that question, my friends, is you can use retrofit. There's actually Playtika, right? Playtika, Feign, something like that, Reactive Feign. Here's a third-party Feign-like thing, a Reactive Feign client. And I expect that this, as far as I understand it, this represents where the Reactive Feign support in OpenFeign itself will go one day, but it's not there yet. And I would love to have the same thing for RSocket. So he had this great idea. What if we had that for RSocket? And I said, well, that's a good idea. So we created a new project. It's called Spring RetroSocket. An homage. It's an experimental thing. You can see it says experimental, brand new, literally days old. But here, you say enable RSocket client. You create an RSocket client interface, and that's it, right? Same as before. You have an interface, message mapping, greetings, etc. You can use variables and all that stuff, destination variables, payload, etc. So lots of really interesting possibilities there. Maybe check back in a month and see if it's worth using. I have no idea. The other thing is I want security, right? I want my application to be secure. It's 2020. Things should be secure. So let's quickly introduce security into our application. Everything I've showed you thus far was not secure. That's not great. So I'm going to bring in all those dependencies. And on the service side, what I'm going to do is I'm going to very quickly use Spring Security to handle two things: authentication and authorization, right? So let's stop this. Goodbye. And here I'll create a configuration class, security config at bean map reactive user details service authentication, return new map reactive user details. So I'm creating a hard-coded username and password. Don't ever do this. You should use something like OAuth, obviously. JLong.password pw.roles user.build. Okay, there's this. And authentication. And now what I want to do is I want to handle authorization. And there's two different bits of authorization that I need to do here. And remember, in a reactive world, things like cryptography, they block. So Spring Security automatically backgrounds that onto a separate scheduler, but you should be aware of that. And if you can use things like OAuth, which actually reduces the times that you're blocking, that's good. Or the times you're doing cryptography, rather. So, okay, server, HTTP security, HTTP authorization, server, HTTP security, security web filter chain. And I'm going to say return http.build. And what I'm doing is I'm locking down access to the endpoint. I'm going to say ae.anyexchange has to be authenticated. I'm going to use HTTP basic, right? I want that. So I'll say x. I want to use customizer's default. I want to disable CSRF. So I'll say x.disable, etc. Okay, so there's my HTTP authorization. I want to do the same thing for RSocket. So I'll do a payload socket acceptor interceptor, RSocket authorization. And here I'm going to use RSocket security, RSocket, return RSocket security dot authorized payload, ap.any exchange has to be authenticated. I'm going to use simple. I can use JWT or OAuth for HTTP, JWT for RSocket, but in this case, I'm just going to use simple, right, which is akin to HTTP basic. So I'll use customizers with defaults, and I think that's it. So then I'm going to build. Okay, so that's the security side. Okay, that's what it's going to look like on the service side. The only other thing that I want to also take advantage of the fact that we're authenticated. So I'm going to customize my code here, my controller. I'm going to build another endpoint that takes the current authenticated user. So I'll say at authenticated principal, mono of user details, right? User. So I'm going to take that, and what I want to do is I want to call the other one, right? I'm going to call this one after I've extracted out the name from the authenticated user in the request. So I'll say user details.mono.map ud.get username dot flat map username to greet, map this to a new greetings request US, and then flat map that gr to this dot greet gr. Okay, so flat map many. There you go. That's the updated code. Okay, so now the only other thing I need to do is I need to teach Spring to know what that annotation does, that authenticated principal. See, the last thing I need to do is to register a handler. Okay, so I'm going to register an RSocket message handler. Okay, and the idea is I'm going to say var mh new RSocket message handler mh dot get that. I'm going to add the authentication principal argument resolver. I'm going to set the RSocket strategies. I'll say RSocket strategies here. Okay, and return mh. Good stuff. So there's the entirety of the code I need for the service. On the client, I just need to talk to that username and password. I need to understand that. So I say private final string username equals JLong. Obviously, you shouldn't hard code usernames and passwords like this ever. PW is PW. And then for RSocket, I need a private final username password metadata, right? I'm going to send this metadata. That's how I'm going to encode the credentials. And I need, for the HTTP stuff, I need a exchange filter function. Exchange basic, simple. Okay. Filter, so exchange filter functions dot HTTP basic, this dot username, this dot password. The other thing I need for RSocket, I forgot, is a MIME type, right? By default, RSocket doesn't know how I'm communicating this. I have to provide a MIME type. So I say MIME type. Okay, MIME type equals MIME type utils dot parse MIME type well known MIME type dot RSocket dot authentication. There you go. Okay, so now we can use this. We can use this to talk to RSocket. We can use this to talk to HTTP. We can do the RSocket communication in two different places. Here's the simple auth. Here's the MIME type. I can do the setup metadata. So when the socket first connects, or if I'm not sharing the connection, if every user, if I have multiple users sharing the same connection, then I probably won't want to do it. I want to do it, per transaction as well. So I can do it down here as well. Notice I also just applied the filter to the HTTP client there. Down here for the for this, I need to provide the setup metadata. So sorry, for just the metadata. So this dot simple auth, this dot MIME type. Okay, and for the data, well, I don't need data anymore. I can just send a mono void, right? Mono dot empty, because the current authenticated user will tell the service everything it needs. The last thing I need to do here is to teach RSocket about how to learn about or understand or read or encode rather the simple authentication. So I create an RSocket strategies customizer, and here x dot encoder new simple. There you go. Okay, that's it. Let's go ahead and restart this. We've already restarted the service. One hopes. Yeah, it looks like it's up. So now, if everything goes to plan, we should see a reactive stream. Wait, there's our client. There you go. And it says hello JLong instead of Spring fans, right? Remember before it said Spring fans? Now it's looking at my current authenticated user. That means it's successfully making the round trip to the other side, getting the data, authenticating itself, and so on. My friends, we've just begun to scratch the surface. I wish we had more time. There's always so much more to learn, especially with this reactive stuff. We didn't look at Spring Cloud Gateway. We didn't look at the application of Kotlin coroutines, which map natively to reactive APIs. We didn't look at Spring integrations, RSocket support. We didn't look at Spring Cloud Streams, sort of very early preliminary RSocket support. We just didn't look at anything, really. I just feel like we've just begun to scratch the surface. I want to thank you for your time. I hope you got something out of this. Please join me tomorrow, and don't forget to tip your waiter. And I'm happy to answer any questions now.
Awesome. Thank you, Josh. We're actually, yeah, there's the applause break. We're 6 minutes over on time. So what we would like you to do is put your Q&As in, and we will have those in for tomorrow on our spring tips. Again, tomorrow, 9 a.m. Pacific Standard Time, same Zoom link. Come on back, enjoy more Josh Long experience, a little bit of me, and also Yvonne on the Q&As, Paul on the ones and twos, and then new Jamie and Tasha on the production side. So we are all so thankful for you joining us today. We know, like Josh said, you have lots of entertainment options, and thank you for choosing ours. So again, tomorrow, 9 a.m., come back in and we'll do just an hour of spring tips from Josh, and that you can get your questions in, and Josh can get you rolling all that. A couple other things just real quick before we leave. Spring One, the big convention, it's all virtual, it's all free. It's September, oh, why am I blanking on it? There it is, September 2nd and 3rd. Yeah, 2nd and 3rd. So go to spring1.io, register, all the tracks are up. Can sign up and just watch so much more spring. Josh will be there. So many more spring people that he even talked about, Medora, Dr. David Sire, Spencer Gibb, blah blah. The list goes on, and I'll be there as well. That's also true.
Everybody on this call will be there too. I'm so excited.
Yes, and then September 29th through the October 1st is VMworld, also virtual, also online. Go register at vmworld.com. There's over 600 tracks and counting, I think, happening over there.
Although to be fair, I could have seen this coming. It's a VM, it's a V conference. It's built in. It's built in. We should have been there.
Virtual, and it's a virtual world we're in. And
yeah, exactly.
They're just living it. Yeah, exactly. There it is. Hey. So anyway, thank you again for your attention. Thank you again to our
stay healthy,
fine crew. Yes, and also safe travels tomorrow. Are you driving back up?
I am today. Yeah.
Yes. So safe travels and get home, and we'll see you tomorrow morning.
Can't wait. See y'all tomorrow.
One love, everybody.